Functions. This lesson requires you to know the basics of hamburger making. Place the bread down. Add the burger patty. Add the pickles. Place the bread on top. What if you had to say each step every time you ordered a hamburger? It's tedious. It takes a long time. How do you fit that on a menu? And it risks making mistakes. In this lesson you will learn a solution to that problem: functions. You'll learn how and why they are used in programming and be able to communicate their benefits to other programmers. Functions are used throughout programming. In fact, some styles of programming rely completely on functions. Knowing this information will be useful for anywhere your programming path takes you. Instructions. Build hamburgers without a function. Make 3 hamburgers by clicking on each instruction. Hint: add bread, add burger patty, add pickles, add bread. Functions for reusability. Instead of giving those instructions for every hamburger, we can group and name them as a single function. Function make hamburger, add bread, add burger patty, add pickles. A function is a named sequence of instructions, packaged as a unit, that performs a specific task. We've defined the function by giving it instructions and a name, but how do we use it? We use a function by calling it. When we call make hamburger, we expect all of its steps to be executed. Instructions. Build hamburgers with a function. In this example you can call the function by clicking the make hamburger button. Make 3 hamburgers by calling the function 3 times. Functions for flexibility. Not everyone wants to eat hamburgers. We could write a new function for each new sandwich type, but that takes a lot of work and risks making mistakes. Instead, we'll generalize the hamburger function to a sandwich function. This new sandwich function will still make a bread topping bread combination, but the toppings may change based on inputs to the function. Function make sandwich, topping 1, topping 2, add bread, add topping 1, add topping 2, add bread. We've renamed the function make sandwich and given it 2 inputs, or parameters. Each time we call the function, we'll give actual values for each input, called arguments. For example, we make a ham and cheese sandwich with make sandwich, ham, cheese. We call the function with the arguments ham and cheese. Those will be the values for the topping 1 and topping 2 parameters. Instead of writing a different function for each type of sandwich, we have one function that can make them all. Instructions. Call the make sandwich function with the arguments ham and cheese. Notice how the instructions change with different inputs. functions for organization. A sandwich wouldn't be complete without fries and dessert. Here are the instructions to make the complete meal. Add bread, add burger patty, add fried potatoes, add pickles, add bread, add salt, add chocolate scoop, add ketchup, add vanilla scoop, add strawberry scoop. Oof! All of the instructions are there, but they're confusing and hard to edit. If you decide to ask for a fruit salad instead of fries, you would have to find all of the fries-related instructions and replace every line. To make it easier to read, we'll separate and organize our instructions. Add bread, add burger patty, add pickles, add bread. Add fried potatoes, add salt, add ketchup. Add chocolate scoop, add vanilla scoop, add strawberry scoop. Better, now let's group these instructions into 3 functions. Make sandwich. Make some fries. Make ice cream. We can easily substitute one line, make some fries, for a different function, like make fruit salad. And if there's an error, we know where to look for the recipe for each part of the meal. The new instructions are starting to look like a program. By using functions, we've made it easier to read, reusable, and modular. Each set of related instructions, sandwich, fries, dessert, is grouped into its own function, which we can easily add, remove, and swap to make a diversity of meals. Instructions. I'd like a sandwich, fries, and triple ice cream scoop, please. Make this lunch without functions. Make this lunch again with functions. Questions. Which approach was easier? Which approach was less prone to error? I'd like 3 sandwiches, 2 fries, and 2 triple ice cream scoop, please. Click the reset icon. Make this lunch without the functions. Make this lunch with functions. Question. Which approach was easier this time? Make this lunch with functions. Putting it all together. Time to get coding. It's okay if you don't recognize all the symbols in this code. We'll walk you through the parts you need to know. The make sandwich function is provided in main.js. It is defined with two parameters, topping 1 and topping 2. By reading the instructions inside the function, we can see that it is constructing a string of words that represent the ingredients in the sandwich. For example, the first ingredient is bread. Below the function definition, the function is called. When called, the function outputs a string representing a custom sandwich. We say that the function returns a string. The value of that string is stored in the variable result. We've set up the workspace so that the value of result is translated to ingredients drawn in the app to the far right, with the below code. Result equals make sandwich, burger patty, pickles. The app will interpret result as a bread patty pickles bread sandwich and draw one to the screen. Instructions. Make a sandwich of your own by calling the function with different arguments. At the bottom of the code, change burger patty and pickles to peanut butter and jelly, then run the code. Congrats, you're coding with JavaScript. Feel free to try other toppings you've seen throughout this lesson. Review. Well done. Functions are a fundamental concept in programming, and learning the basics will serve you wherever your path leads, regardless of language or domain. To review, a function is a sequence of instructions that performs a specific task, packaged as a unit. When we define a function, we specify the instructions, inputs, and name of the function. When we call a function, all of its instructions are executed. Functions can be executed many times, making its instructions reusable. Functions can have parameters, which accept input values, making its instructions flexible. Functions organize a program into distinct units, making interchanging and editing them easier. This makes your entire program organized and modular. Instructions. Make sure you're comfortable with the above concepts before moving on. When a function's name, inputs, and instructions are specified, we can say that the function is defined, called, executed, correct. What are some benefits of using functions in a program? Less lines of code, brittleness and disorganization, reusability, flexibility, organization. Correct. Fill in the blank. When we define a function, its inputs are called underscore underscore underscore. Each time we call the function, we'll give actual values for each input, called underscore underscore underscore. Parameters, arguments, arguments, parameters. Correct. Parameters and arguments are both inputs to a function. Parameters refer abstractly to a function's inputs and arguments are the actual values inputted. Which one of the following statements is true about functions? When an instruction step is executed, all functions that share that step are also executed. Functions cannot be defined. Functions are reusable sets of statements, grouped to perform a task. No, but the converse is true. If a function is executed, all of its instruction steps are executed. When a function is called, it lists all of its steps. It is defined. All of its steps are executed. It picks up the phone. Correct. Quiz scorecard. 80%. Control flow. How do computers make decisions? Here are a few examples. Web surfing. Open the browser, load the text, load the images. Social media. If the user's profile is private, hide their posts. Otherwise, make them visible. Electronic music. Repeat a note 4 times a measure. Shopping. Collect shipping and contact information. Reject a purchase if either is incorrect. Each of these programs is a set of instructions, executed in a certain order. This order, called control flow, is just as important as the instructions themselves. Programmers use control structures to alter control flow. Control structures include conditionals. Do these instructions if Z is true, loops. Do these instructions X many times, and exceptions. Do instruction set A, but if an error occurs, switch to instruction set B. Programmers use these structures in their code to tell a computer which instructions, or in which order, to execute. In this lesson you will learn the fundamental concepts of control flow and 3 essential control structures. By the end of the lesson you should be able to define control flow, explain the difference between conditional, loop, and exception control structures, give examples for each. Instructions. There are 5 steps in this program, which loads a basic website. Execute the steps in the correct order by clicking each one. In what order are the instructions executed? Conditional. If the user's profile is private, hide their posts. Otherwise, make them visible. Computers can run instructions on their own, leaving us to work on more interesting and creative problems. But computers can't make decisions on their own. Programmers can give them multiple sets of instructions and describe the right conditions in which to use each set. They can describe a structure like the quoted program above. If X, then do instruction set 1. otherwise to instruction set 2. This structure is called a conditional control structure because the computer's instructions depend on some condition S. In our social media example, all the instructions are shown in the diagram, but only some of them will be executed each time. Here they are in text form. Check profile privacy. Hide the post. Show the post. When is step 2 executed and when is 3 executed? The answer is, it depends. The control flow is 1-2 if the profile is private and 1-3 if the profile is public. The condition is the privacy setting on the profile. Conditional control structures, or just conditionals, allow programs to do different things in different scenarios. As you can see, they follow a logic similar to how humans think, making it easy to write clear code while still handling complex processes. Instructions. Select Make Profile Public, then click through each step of the conditional structure. Select Make Profile Private, then click through each step of the conditional structure. What's the control flow for each? Loop. Repeat a sound 4 times a measure. Computers are good at repetitive tasks. They exactly follow instructions and perform them quickly. But if the programmer has to write the same instructions for every repetition, they waste time and increase the chances of a mistake. In our example, instead of literally writing, play a sound, play a sound, play a sound, play a sound, programmers can use a loop structure. A loop is a sequence of instructions which is specified once but which may be carried out several times in a row. In this case, there is one instruction, play a sound, and it should be carried out 4 times. Loop structures can also specify that the instructions are repeated until a certain condition is met. For example, repeat a sound until you are booted off stage. Instructions. Click the shapes in the diagram to move through each step of the loop structure. What is the condition or count that must be met to stop looping? Exception. Collect shipping and email address. Reject a purchase if either is incorrect. Errors, or exceptions, happen all the time in programming. You can't escape them, but you can handle them gracefully. In exception handling, 2 sets of instructions are defined. The first set is executed, and if an exception occurs, the first set is stopped and the second set of instructions is executed. In this example, the first set is collect shipping address, collect email address. The second set is reject the purchase. If any errors occur in executing the first set, maybe the address is incorrectly formatted, or fake, it is stopped and the second set is executed. These statements are useful if you know an exception may occur in a set of instructions but you don't know in which one, or you expect the same exception might occur in multiple, sequential instructions. Instructions. set the shipping and contact information, then click through the exception structure. What happens when you select a fake address and a real email? What happens when you select a real address and a fake email? Putting it all together, let's recreate the conditional control structure using JavaScript, the one about social media posts, remember? The control flow shown above is written as a conditional control structure in main.js. It looks something like this. If condition, do something else, do something different. If the condition evaluates to true, the computer will execute the body of that statement. In this case, it's do something. If the condition is false, the computer will execute the body of the else statement. In this case, it's do something different. Let's adapt this general template to our example. The condition is true when the privacy mode is set to public. This is already written for you in main.js. You'll replace do something with a JavaScript function, show details. You'll replace do something different with another function, hide details. The instructions below will show you how to do this in code. Instructions. Complete the control structure by calling the functions below. If the mode is public, call show details. Else, call hide details. Run the code and test the website. If done correctly, the content of the post should be visible when you choose Make Profile Public in the drop-down, and the content of the post should be hidden when you choose Make Profile Private. Review. Well done. Control flow is a fundamental concept in programming, and learning the basics will serve you wherever your path leads, regardless of language or domain. In review, control flow is the order in which instructions are executed. Control structures alter control flow in a program. You learn 3 structures, each suited for a different scenario. Conditional. If some condition is met, then do X, otherwise, do Y. Loop. do something z number of times, or do something repeatedly until some condition is met. Exception. Do steps A, B, C. If an error occurs, stop, and do steps J, K, L. Instructions. Make sure you're comfortable with the above concepts before moving on. Which of these best describes an exception control structure? A set of instructions is repeated if an error occurs during its execution. A set of instructions is executed. If an exception occurs, that set's execution is stopped and a second set of instructions is executed. A set of instructions is executed repeatedly until an exception occurs. Correct. Define control flow. The condition that must be met to execute a conditional statement. A structure used to alter the order of execution in a program. The order of execution in a program. A program. Correct. One of these programs uses a conditional control structure. Which one is it? Do something z number of times, or do something repeatedly until some condition is met. Do steps A, B, C. If an error occurs, stop, and do steps J, K, L. If some condition is met, then do X, otherwise, do Y. Correct. Fill in the blank. Control structures, such as underscore underscore underscore, allow for underscore 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 to be altered during the execution of a program. Correct. Conditionals are one type of control structures. All control structures alter control flow. Which of these best describes a loop? A control structure that executes a set of instructions unless an error occurs. A control structure that executes a set of instructions if a specified condition is true. A control structure that repeats a set of instructions until a specified condition is met. Correct. Quiz scorecard. 100%. Cheat sheets. Basics of programming 2. Conditional control. Conditional statements or conditional control structures allow a program to have different behaviors depending on certain conditions being met. Intuitively, this mimics the way humans make simple decisions and act upon them. For example, reasoning about whether to go outside might look like: condition: is it raining outside? If it is raining outside, then bring an umbrella. Otherwise, do not bring an umbrella. We could keep adding clauses to make our reasoning more sophisticated, such as, if it is sunny, then wear sunscreen. Control flow. In programming, control flow is the order in which statements and instructions are executed. Programmers are able to change a program's control flow using control structures such as conditionals. Being able to alter a program's control flow is powerful, as it lets us adapt a running program's behavior depending on the state of the program. For example, suppose a user is using a banking application and wants to withdraw $500. We certainly want the application to behave differently depending on whether the user has $20 or $1,000 in their bank account.